Okay, let's finish up this section with the actual application of completing the square. Now, this isn't any magic bullet or anything. It's just another method to to solve a quadratic equation. You can use it anytime you want. That's the one thing nice about it. There's no really restrictions to it. We're going to be creating a perfect square trinomial, so we're kind of forcing the issue. And there's so it's one of those ways you can use it. We'll see it again when we talk about transforming quadratics. So it's a good skill to have for us. It makes our life easier in that respect as well. So completing the square. The one difference here is that you're not letting things equal to 0. We're going to make things equal to our constant. So the first thing we want to do as we go through this is make things equal to our constant. So 12 is our constant. We're going to subtract 12 from both sides first. And we'll have x squared minus 4x equals negative 12. Now this is equal to 0 at this point. It'd be great because I could just factor out an x and then solve using my zero product property. But I don't have that, so I can't use it. So we're going to create a perfect square trinomial. Now remember, this idea of equality in math is important because what it allows us to do is manipulate the left side. And as long as I do the same thing to the right-hand side, I can do whatever I want. So we're going to manipulate this now. The first thing we need to look at is our first term, x squared. Okay, x squared must have a leading coefficient of 1. If not, we need to divide everything out to get there. And so to create a perfect square, what we're going to do is, this is my b term. This is b right here, right? So what I'm going to do is do b divided by 2 and then square it. Okay, and that's going to give me something to add to both sides, and then that'll help me create a perfect square. So if I take b, which is negative 4, it's negative 4 over 2, and if I square that, I'm going to get a positive 4. Okay, so that's what I'm going to take and add to both sides. So I'm going to have x squared minus 4x. I have a plus 4 will equal negative 12, also plus 4. Again, I haven't changed the value of the problem because I added 4 to the left side and I added 4 to the right side. So the problem itself has not changed. These are the exact same thing. That's the power of equality when we deal with math. So what that gives us on the right, that gives us a negative 8. Okay, that's fine. But the left side, it creates a perfect square trinomial. And as we said in our last video, okay, all this stuff up here, I can factor that really easy. This is what we did last time. Okay, this makes it simple as we go through and factor that. So what this factors down to, okay, as I look at that, this first one is 1x squared, so that's just an x. Okay, the square root of 4 is 2, and then take the middle sign, it's minus. So where this came from, x is x and x. 4 is 2 and 2, and that's where those two things came from. If I do 2 times 2x, that gives me 4x. That's my middle term. That's great. Those two pieces go in there, and that gives us what we want. All right, so now, just like before in the last video, I can solve this equation fairly easily. I have something squared equals a result, so I take the square root of both sides. Okay, that gives me x minus 2 equals, remember, plus or minus, that's the new part, the square root of negative 8. Okay, well, I can simplify this. First thing that sticks out is the negative. So I have to take out plus or minus an I, and then 8 gets simplified. That's 2 and 4, just 2 and 2. And there's a pair of 2's, so I can bring out a 2 with that I, and I have a 2 left over. Okay, so I'm almost there, but I have to take care of this 2 now over here. So I add 2 to both sides, add 2 to both sides. So x will equal 2 plus or minus 2i squared root of 2. And that's my exact answer. Okay, and again, we want the exact answers because they're more accurate than rounding stuff. I have an I in there, so that's going to change it as well. So if I go back and look at again what I did real quick, this is a little review. Okay, I don't have a perfect square trinomial. I can't factor it because there's no factors of 12 that add to 4. That doesn't work. So I have to force the issue a little bit. But again, this idea of completing the square, it creates a perfect square trinomial that can factor into something I can take the square root of. And from there, I just simplified the square root portion of it. Okay, again, how I make a perfect square, I take my middle term, my middle coefficient, I divide it by 2, then square it. That result is added to both sides of the equation. Okay? And what we'll see in future chapters is we're actually going to use this idea to help us graph and talk about transformations of a quadratic equation as well, and compare the graphs of them. And we use it to put it in what we call vertex form um, as we go. So that's your example of completing the square. Again, the difference here is instead of equaling 0, it's equal to its constant. So that's the first step we took. And then we created a perfect square by doing the b over 2 squared. Okay, don't get that confused with the b over 2a from your vertex that we did when we graphed it. There's no 2a, it's just b over 2. And then we added that result to both sides. Okay, that created a factored perfect square. We took the square root of both sides and simplified the square root portion, and then just got x by itself. And that gave us our final result. So that's completing the square. That's section 4.5. It's a whole lot of stuff there, but and take it piece by piece. The key is the perfect square, and that's where we went, and that's where we began and finished with completing the square. So that's the end of the section. Hope that helps, and we will see you guys in class.